All right, class. Yes, I know it's kind of weird me doing this, even though that I'm in a classroom here by myself talking to myself, but still, try to get your attention every once in a while. So we're going to go through and do 7.3. We're going to do a little bit with 7.3, not too much, but we're going to talk about the law of cosine. One of the things I want to bring up also is right here. So this is actually our lesson. This is actually 7.3. Homework problem right here. There is two parts to the homework, so I'm going to try and get as much into this video, but not try to exceed maybe 15, 20 minutes at the most. So I'm hoping you will actually come in, take the notes, and when you come in on a class on Friday, you could actually have this down so you could actually start doing the work in class and not need to go back over this again. So law of cosine. Triangle side length resolution. We already talked about this. The greatest side goes along with the shortest side. Blah, blah, blah. Blah, 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 blah. All this is kind of interesting, but we're going to do some more with this where this is, I really don't feel as if this really makes sense unless you, I don't know. I really don't think it does. So it speaks nerd, and if you are fluent in nerd, then hopefully you should be able to get this. Here we go. So law of cosine. Here is going to be our three formulas for law of cosine. So in any triangle with sides A, B, and C, we have these formulas. But I don't like the way that they set this up because they solve it for A squared, B squared, or C squared, where we're not really looking for the A. It says right here we're looking for A squared. But there's an easy way. Since this is going to be the sides of a triangle, and in those sides of a triangle, it's going to be a distance. It's going to be a length. I cannot have a negative distance or a negative length. So when I do this, I can actually just set this up a little bit easier. So instead of just saying A squared is equal to, I could say A is equal to. And whenever I take the square root to undo that square, I'm going to do the plus or minus. But like I just said, this is talking about a length of a side of a triangle. So I'm not going to have a negative value here. So I'm going to rewrite these. And it's going to be A is equal to the square root of, and if you notice, I'm not doing plus or minus, because again, it's always going to be a positive value here. That's B squared plus C squared minus 2BC cosine of big A. So you notice right here, to solve for little a, I have to have little b, little c, and big A. That's important. So when we're identifying what we have, we can figure out what formula we're using. Same thing for b. So b is equal to the square root of, that's going to be a squared plus c squared minus 2ac cosine of big B. C is equal to the square root of, that's a squared plus b squared minus 2ab cosine of big C. So if you need to copy this down, go ahead, pause it. I don't want to make an extra long videos for this. So pause it, write down your formulas for this. So C in the right triangle, it's actually just going to come out to be the Pythagorean theorem anyway. Now, given this right here, this is actually an example of what we have. So we're going to go through and look to see the values that are given to me. This is an ABC triangle. I'm looking for little c. So if I'm looking for little c, that means I have to have little b and I have little a. So I got both those. So that means from that formula that I was just looking at, I'm going to have little b, little a, and if I'm looking for little c, I have to know what big C is, and I know that one here. So since I have this set up, I already have it, even though that it is going to be this, and this is going to be pretty basic for all the problems that we're going to have to deal with. You have to identify the values that we have, and then from there we could use either law of sine or law of cosine. But as what we're dealing with today, it's always going to be cosines. So I'm going to go to the next page. Come on now. There we go. All right. There we go. So little c is equal to the square root of a squared b squared minus 2ab cosine of big C. So let's plug in, little c is equal to the square root of, so I'm going to go back and forth with this. So this one is 423 plus b, which is 259, minus 2 times 423, 259, times cosine of my angle, which is 132.40. 132 degrees, 40 minutes. And so when we do this, all this has to be inside that radical. And I'm going to bring this up here. There it is. All right, should have had it loaded at first, so apologize for that. There we go. So scratch pad. I'm in degrees. So I'm going to start off control square root. So my formula was going to be 423 squared plus 259 squared minus 2 times, make sure I wrote that down, yeah. 423 close 259 close times cosine of 132 degrees, 40 minutes. There we go. And if you notice, everything here is inside this giant parentheses here. So when I go ahead, hit enter, I'm going to get an answer. So little a is going to be 628.10. So let's go right here. Little c is going to be about 628.10. Did I just set that down? I think I did. It's in my hand. So little c, and let's go ahead. What are my units? Meters. So it's going to be meters. There we go. And so there we go. That's all we needed. So it was just solving for this missing side right here. So find the distance c. So we don't have to solve for the whole thing. We're just solving for one of the sides. And that's going to bring me up to example 2. Now this one on example 2 says solve the triangle. All right, so we're going to go through and solve the triangle. So I could do a lot with this. So since I am looking for a side, but I only have one angle. So if I was to use law of sine, I would have to have a pair. I'd have to have big A and little a. But since I don't have little a, but I do have big A, since I have that, I'm going to end up having to use law of cosine first. Because the way that this is set up, law of sine, I would have to have little a, big A. But if you notice, I'm looking for little a. I have little b, I have little c, and I have big A. So I'm going to go ahead and set that up to solve for little a using my formula that I have. So little a is equal to, and this one right here, we're going to solve everything here. So that means I'm going to solve all the sides and all the angles. So little a is equal to the square root of, that's going to be 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3 degrees. And so make sure all that's inside my radical. And so I know I might be going a little bit fast on this, but you have a pause button. There we go. So my control divide, and I'm going to go with my values, which is going to be 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3, and make sure I add my degrees there. There we go, and I'm going to hit enter, and I'm going to get about 10.5. And I'm going to round it to a tenth here because my other sides were already round to a tenth. So that's going to be about 10.5 is going to be my little a. And meters, there we go. So now that I have that, I now have all three sides. Now I can go through and solve for using law of sines to find my missing angles. And right here it says B is less than C since it's opposite. B is less than C. It's opposite of the two sides. Therefore, B cannot be obtuse. So that goes along with largest side, largest angle. So because of this right here, where little b is 12.9, little c is 15.4, little c has to be bigger than little b. So what I'm going to do is I'm going to go ahead and solve for angle B. I'm going to use law of sine. I'm going to do angle B. Come on now. You know what? Right here. So I'm going to solve for angle B. So 10.5 over sine 42.3 is equal to, so I said I'm going to solve for angle B. So it's going to be sine of angle B down here on the bottom, and then my little b here was 12.9. So again, I'm going to do the cross products, but because you really don't need to go through this every single time, I've taught you guys how to do this, so I'm going to jump straight to this. So I'm going to end up being, after I do my cross products, angle B is equal to inverse sine of 12.9 times the sine of 42.3 degrees divided by 10.5. And I'm going to put this in my handy dandy calculator. So it was 12.9 sine of 42.3 over 10.5. And hit enter. There we go. And so this one's going to be my angle. My angle here is going to be 55.8. So I'm going to say it's about 55.8. So capital B, 55. Sorry. So to find my last angle, since I already have all three sides, to find my last angle, I'm going to do, so angle A, we said was 42.3 plus angle B, which is 55.8, plus angle C is equal to 180. Remember, all three angles together have to add up to 180. So I'm going to take those and I'm going to go ahead and subtract from 180. Like this, and I get 81.9. So my angle C is going to be about 81.9 degrees. So we've gone through, we solved for all angles and sides. Sorry, there we go. So this is going to be 81.9. There we go. 81.9 degrees, and we said this one was B was 55.8. So I've solved for all angles and sides, and I'm going to leave off there for example 2, and then we're going to pick up some more on Friday. So don't forget, like, share, and subscribe. Hit that notification button, and use the promo code DJ Versailles. Get 10% off the merch store.